Okay, we're here at gotomath.com. I had to take a deep breath on that. Let's do hyperbolic functions. Let's go down to there, and we're at 4.1. And it looks like, whoa, we got the integral sign here. Find the indefinite integral. All right. And, okay, so remember back when we found the integrals of like cosine x dx? Well, that was something we just had to memorize, and similar going on here, except I added just a little bit extra. So we don't have to just memorize the hyperbolic cosine of x. Alright, so let's go ahead and write this down. We got x to the fourth. Maybe I better write it down so I can remember it, but that gives you time to write it down. I highly suggest that you write it down. Alright. Okay, so let's move over to the whiteboard. Now, I'm just going to go ahead and write something out right over here. Well, let's go ahead and write the problem first, I guess. So we got the integral of x to the fourth and then cosine h, it's hyperbolic cosine, and this is x to the fifth dx. I'm surprised I don't have a coefficient in here somewhere, okay, other than 1. Now this is what I'm going to write. I'm going to write this right over here somewhere. Put a little line divider. So we got the integral, so this is just in general here. Cosine h of u, where u is a function, du, is equal to sine h of u, and then of course you should know what's coming next, plus c, right? Okay, so u is just a function here, all right? And what I mean by that, for example, x to the fifth could be written as a function. F of x is equal to x to the fifth. All right. Okay, well, here's the story, and that is that we have this x to the fourth out here. So you should look at this and go, hey, if I took the derivative of this, we'd get x to the, or 5x to the fourth, and there's our x to the fourth, right? So we're going to have to use u substitution. Now, this u here is basically the name of a function here, but this is just the name of variables. So don't let this u get mixed up with what's going on here. Just totally separate this stuff from what we're doing here. All right. So we're going to let u be x to the fifth, and then we're going to take the derivative. So du is equal to 5x to the fourth dx. All right. Well, we have an x to the fourth and we have a dx, but we don't have a 5. So in order to substitute in for these guys, what we're going to do is I'm just going to go ahead and take this 5 diagonally down, or technically we're multiplying both sides by 1/5. So now we can substitute the x to the fourth and the dx, we can substitute it in for the 1/5 du. Except I always take this 1/5, and instead of writing it over here, I'll take it and just bring it on out to the very front of the integral there and get it out of the way. Alright, so we'll write a 1 here. This kind of well, the x to the fourth and the dx, you see, right, is equal to the du 1/5. I take the 1/5 outside, but then we're left with the du, but I write that du right over here instead of writing it up here in the top. And I'm not exactly sure why I did that, so let's hold on just a second. Okay, I had to erase that. I don't know what I was doing. So I'm going to rewrite the cosine h of u here. All right. So the integral of cosine, hyperbolic cosine, you should say, is sine. But now let's carry that 1/5 now. Don't forget that. So this is going to be sine h of u plus c. All right. But we want to get everything back in terms of x, so we say 1/5 sine h. We get everything in terms of one, or get everything in terms of x again. So u is equal to x to the fifth. So substitute back in x to the fifth plus c, and we are done. All right, we are done. So let's hit the answer there. Make sure that's all good. It all looks good. All right, so come on back to gotomath.com. You come on over here, practice. We got thousands of math problems. All right, bye.